I'm Kostiantyn, and I'm from the company called Bolt. We are going to talk about how we implemented Lakehouse architecture at Bolt using Presto. Probably gonna skip over some content to make it faster. We'll see. So yeah, blah, blah, blah. This is me. I would skip this. We are going to talk about Bolt, how we transitioned to Lakehouse, and which challenges did we face along this transition? Why did we decide to do this transition in the first place? Why did we choose Presto? And yeah, some of the learnings we've made and some future work that we would like to focus on. Quickly about Bolt, we are a company from Estonia, which is a small country on the north of Europe, but with pretty rich startup scene. We have over 100 million users at the moment, and we operate in 45 different countries, mostly in Europe and Africa, but as you see from the map, we are present in other regions as well. We do not operate in US. We are a mobility app, so we cover wide range of verticals from car rides or ride-hailing, scooters, and micromobility, food delivery, car sharing, and grocery store delivery. Okay, so I'm going to start with talking through what our data platform architecture looked like couple of years ago before we started the change. On the left side, you see different data sources that we ingest our data from. A lot of them are our backend databases, which we replicate data from using change data capture, using Debezium with MySQL and TyCDC with TyDB. We also stream some events just from backend services to Kafka for analytical purposes, which do not get stored to the operational databases. And also, we have various third-party integrations, some custom, some using some generic tools like Fivetran. In the end, this data ends up in S3. So as you might have guessed from this, we are on AWS. And the raw data is then ingested into our data warehouse using some custom scripts or Spark. And at that point of time, we had Redshift as our main centralized data warehouse solution. And we also stored some data on S3, mostly immutable data because we didn't deal with formats like Parquet or Iceberg, well, not Parquet, or like Delta Lake, Iceberg, or Hoodie to actually deal with mutable data on S3. All the mutable data was handled by Redshift. We were quite heavy users of Spark at the time already, so we use Spark for processing data after it gets into the data lake. But it was more complicated, I would say, because a lot of this data needed to be unloaded from Redshift first. And on AWS, we used Glue as our main data catalog. For BI, we used and still use Looker. And this is our major, I would say, use case for the data platform, because speaking of our scale, we have over 2,000 internal users using the platform that are ops people, BI people, analysts, data scientists, that all heavily rely on Looker, among other things. Covering some other numbers, yeah, we have multi-petabyte data lake, and mostly we don't store like plain text or some application logs. So these are, for the most part, just compressed Parquet tables with quite relevant data. We peak at 100K plus queries per day, which is part of the issues that we were facing is high seasonality of our load. We have much higher usage of the platform on Mondays. And as you know, these kinds of seasonal workloads and scaling for them might not be so easy to manage. Yeah. We also have a lot of complicated queries. I wrote 50 plus joins here. Some have a lot more. We have some SQLs coming from lookers that are like 2,000-3,000 lines of SQL code. Okay, so speaking about the challenges that we faced with the architecture. First one is that we were simply hitting scalability limits with Redshift as it is. We were relying on a single centralized Redshift cluster to handle everything. And it was working fine up to a point, but we reached a point where scaling Redshift further was just not cost efficient. As you may know, distributed systems do not scale linearly. Another thing which I've already briefly covered is that we had trouble scaling up to the peak load. It also somewhat is related to us using Redshift because Redshift has elastic resize, but you can't do it too many times per day. And so it's hard to do something like actual auto-scaling. And with highly seasonal loads, this is problematic. Another thing is that we had all kinds of different workloads on the same cluster, from ingestion to processing to just people running their queries from their IDEs or SQL clients. And this can cause problems when one workload kills everything else. And we did have quite a few situations where some heavy transformation jobs impacted, for example, ingestion, and it slowed down. Cost attribution was also a problem, so we didn't have great visibility into which teams or users contribute to the majority of our Redshift costs, which were pretty high. Okay, so with that in mind, we decided to evaluate some different architecture. We were not set on Lakehouse at the time, but it ended up being Lakehouse, and I'll briefly talk about why. So we tested a number of big players in the market. One of the natural choices was RE3 nodes from Redshift. I'm not going to talk about why they didn't work out for us. They offer some separation of storage and compute, but let's say we faced some limitations that made it not work in our case. If you are interested why, please reach out, but I don't have time to cover it now. Others that we did some POCs with were BigQuery, Snowflake, different kinds of Presto, including running it on EMR, in AWS, or even running it just ourselves. And we also tried Trina. We tried Databricks, SQL Analytics solution. And at the end, we've looked at it from a number of vectors, I would say. One of them was price performance. Another was we wanted something more open so that we are not locked in by a single vendor like we were with Redshift. And the third, I guess, was the ease of implementation, because we wanted to make this shift pretty fast. And it was already a highly complicated project. So in the end, we decided to choose HANA as our partner to implement Presto at Bolt. And that allowed us to save a lot of time on building out Presto infrastructure, because that's what HANA offers. Managed Presto infrastructure, which runs within your AWS account on EKS. Okay, so with that in mind, we went on to start the migration. And it was a very big and challenging project. We had hundreds of existing jobs, thousands of tables, that we needed to migrate to the new architecture. And it wasn't like a simple one-to-one migration, like you might have hoped. We needed to adapt a lot of our queries and data layout to work better with Presto. We didn't do the best job in all of these cases, but some level of change was necessary to make things work. Another thing that we did is just a big cleanup of everything that we had. It's very funny that whenever you ask if we can clean up something, people say no, but when they need to migrate it, suddenly there is stuff to clean up. We also needed to build out a lot of tools and documentation and enable self-service for the teams. That was important, so they could migrate their workloads, dashboards, jobs themselves. So I would say that self-service aspect was crucial to enabling the success of the migration, because otherwise, with our resources, we would not be able to achieve it, at least in the time frames that we did. We also needed to keep the business up and running, so we had to run both the old warehouse solution and Lakehouse at the same time. So for that, we've implemented some data synchronization between the two, even for derived tables. So even if the transformation job still runs on Redshift infra, we just sync the results to Lakehouse and can enable migrating downstream consumers before that part is migrated. So that allowed us to kind of work on everything in parallel rather than manage all these dependencies. And the last important bit, I guess, is data consistency verification. So it has been very important at the end to verify that behavior of all our jobs and ingestions is the same across the two systems. And we had to invest quite heavily into it. And one learning that I would have from this project is that we probably should have done it even a lot earlier than we did. Okay, so I'll cover the timeline for the migration. It took a little bit over a year, I would say. Our POC, when we evaluated different solutions, started in November 2021. We put some basic architecture in place in Q2 2022. And really from June to October, we were focusing on just getting the data into the new solution and having tooling and documentation ready for the migration. And the migration itself happened actually over Q4 of 2022. And it was a success. We were able to completely sunset Redshift, which I would say is impressive for just 1 year. But are we done here? So I kind of got drunk at the end of it. And when I came back from my hangover, we had still a lot of issues to solve. But I'll talk about it in a bit. I just want to recap the architecture that we had. And this is the new architecture. So what changed? Basically, we rebuilt our entire ingestion pipeline to use structured Spark streaming to ingest our data sources from Kafka into S3 Lakehouse using Delta Lake as a format. Why Delta Lake? Because we also started using Databricks around that time, and we wanted a format that is very well integrated with one of our query engines at least. There were some challenges integrating it with Presto, but we've managed to work around it. And all our processing now directly can read data from S3. And our batch use cases, we, for the most part, run on Spark. And we use dbt to actually write the jobs themselves. And Presto replaced Redshift as a query engine for our BI. So we use over 10 different Presto clusters now to power our Looker instances for different business verticals. And we still use AWS Glue as our data catalog. It's like connected to everything and actually is kind of a single point of failure in this architecture. So it's important that it performs well. Yeah, so talking about the issues that we faced just after the migration. First was related to some specifics of AWS at the scale and caching. So we had issues with S3 and with Glue performance. With S3, part of it was because we potentially might be the biggest company using Presto and Delta. I'm not sure about this, but I have a suspicion that we are. And talking about Delta, there was no caching for Delta manifests in Presto code base at that point. And for tables with lots of partitions, it ended up doing like crazy amounts of list requests. And our costs for just the 3 list requests were like 10% of our total Presto cost at some point. So we were able, collaborating with HANA, to patch this issue. And yeah, that was one of the things that we had to work on, but we also had to work on some optimizations of metadata caching because we have a lot of metadata, tons of tables, tons of partitions. We had problems with high eviction rates for the metadata cache, so we had to do some tuning there to reduce time of query planning. Yeah, some other things that came up. So as you know, Query Optimizer needs stats, but if you have a lot of tables and data, stats collection itself can be a challenging process. And yeah, we had to implement some mechanism to detect which partitions have been changed to kind of reactively collect stats for these. This is based basically on just listening to change events for the S3 bucket and picking up changes either for Delta manifest files or just like Spark commit files. Yeah, and there were also a number of bugs that we also had to fix together, collaborating with HANA in terms of some edge cases, I would say, where stats were not collected at all or not collected properly. Some other things that we've encountered is originally we haven't sized or split our workloads properly. So we faced some crashes with out of memory and performance degradations, mostly related to memory management. So some takeaways from this is like, we kind of knew this, but due to some tight deadlines, we still fell into this trap a little bit, is that you want to split your workloads as much as possible. So the more isolation and different clusters you have, the better and the less chances you would run into these problems. So some of these still need some investigation and potentially code fixes. And another thing is, yeah, we had to do some tweaking of Presto memory settings and instance types based on our workloads. Autoscaling. So I would say one thing with autoscaling that is problematic in our experience with Presto is very high peaks of load, because as you may know, Presto, even if it scales up, it won't reschedule currently executing queries on new nodes. So this may result to elevated failure rates. And I think community might be working on improving this at some point. But for now, what we kind of came up with is we know our load patterns sort of. So we use a mix of autoscaling and scheduled scaling to preheat clusters when the huge load spike is about to hit. And yeah, we had to remove a lot of, let's say, not relevant workloads that we've identified during this migration. And the tight deadlines also meant that we haven't optimized everything for Presto. And I would say that generally the biggest thing that you can do for your data infrastructure to perform better is actually optimizing how you model the data and how you build queries, etc. So like, don't expect a new query engine to magically fix all these problems. Yeah, speaking of costs, one takeaway I to mention is that you don't want to try to optimize costs and do this complex migration at the same time, as we learned. And another thing that we currently see a lot of potential in terms of cost savings is just utilizing spot instances on AWS. Okay, so with that in mind, what we were able to achieve. One thing is we don't have any more fires due to Monday peak load, which is a big thing. We've reduced our average query runtime by, ballpark, I would say 30%. It depends use case by use case. Important thing to note here is that we had sometimes even trouble explaining to our users is that Presto is not really faster than Redshift, but it is more scalable. So the improvement here is because we are able to have more throughput and less queuing in our system now. But if you just run a single query against like a big Presto cluster or Redshift cluster, Redshift actually might perform better. But with Presto, you obviously get the scale. Reduction in blast radius. So issues are more localized now. We don't have problems where some bad query breaks ingestion or some other workflow. And that's not directly related to Presto, but that was a benefit of the architectural changes that we did with this migration is big improvements to self-service. So right now, actually, we can solve like 98% of ingestion cases and data transformation cases without involving the data platform team, so analysts can just self-serve these. We've stabilized the costs. I wouldn't say that we had some like huge gains in terms of cost efficiency at the moment, but we do see some good opportunities to like improve the situation by switching to spot instances and actually get ahead of what we have with Redshift. Future work. So here I would like to address the audience actually a little bit. One thing that we are struggling with at the moment is controlling access to the data from all the different tools that we have. It's Presto, obviously, but it's also Looker, it's Spark, and potentially there can be more tools in your stack. And all of these have their own security models, like we use Ranger with Presto. For Spark, we just control access via IAM on AWS at the moment, but it's a nightmare. There really needs to be some centralized solution for managing all these across your stack, but from our investigation so far, we haven't found it yet. Maybe we'll have to build it. But if you know something, please reach out, and obviously if you want to. Another thing is query level observability. So we have better cost attribution now. We know how much money we spend per vertical. But what we really want to understand is how much each individual query, let's say, originating from some dashboard costs, and how do we properly track this down and attribute these costs, and how do we potentially detect bad actors and block them or reach out to them automatically before they even become a problem. So, for example, right now, when someone runs an overly complicated query in Presto, it will still consume lots of resources before failing eventually, because it runs out of limits. Ideally, we would want to use some history-based strategies that would prevent this in the first place and not allow submitting such a query. We will also be looking at improving Delta integration, I think, at some point. Right now, we just use Hive connector and Symlink tables, so we do not even use Delta connector with Presto. Further fine-tuning autoscaling might be some opportunity for further cost savings. We've discussed that CPU-based strategy is not ideal in some cases, and we might look, for example, into scaling based on queue sizes. And Velox is obviously one of the projects that the entire Presto community is excited about, and we're excited about trying it out too. So yeah, with that in mind, we are Bolt, and yeah, we are hiring. If you're interested, please reach out. And yeah, I don't know if you have time for Q&A. Okay, we have some questions. You said you use dbt and Spark for transformation. Why both? So, well, dbt still needs to run on some execution engine, which we use Spark for. dbt was chosen to be used on top of Spark to simplify, I would say, writing our jobs for analysts, because they generally just want to write SQL and they don't care about Spark and Spark infrastructure. So dbt has enabled us to have code reuse with SQL, proper lineage, incremental computations. It's actually a very cool tool, and I would highly recommend looking into it if you haven't already. Can you expand more on how reduction in blast radius was solved with Presto? Yeah, so originally we had one Redshift cluster where all the workloads were competing for resources and could affect each other. And now we have, I think, over 10 different Presto clusters just for BI. And some of the workloads that we had has moved to Spark, where we use just disposable clusters for each job. So right now, the blast radius is reduced to that particular cluster. Like, for example, we have a separate cluster for like delivery analytics. And if they have issues, it's only they who have issues, but they don't affect other verticals. What challenges did you face with Trino compared to Presto? I believe Trino scales better. So ultimately, I would say we got comparable performance results out of both in our benchmarks. One thing that sold us on Presto over Trino is vision of the Presto community to build the best and most performant engine for Lakehouse, whereas Trino, I think, is more focused on the data mesh story and various connectors, which we do not feel like we need that much. I would also say that part of it was HANA was hugely cooperative during the POC stage, so we felt like they were just more responsive. Okay, yeah, then thanks everyone. I guess that's it.